Now let's move on to the facets of awareness. Affect. As I said, it's the territory of emotion and feeling, and it's always present. There is no, in these terms, from a human operating system point of view, it's not like sometimes you're emotional and sometimes you aren't. There's always some level there. It's diverse. You don't just have a positive emotion and a negative emotion. You have things like fear and disgust, and that you could consider both, adverse kinds of emotions, but they're very different. Lots of other emotions come in there as well. It's motivational. Essentially, all decision-making, regardless of whether people call it rational or not, is all fundamentally, I would say, based or at least associated with emotion. And one of the ways in which this is made clear is that people who have had brain injuries that have damaged parts of their brain that are really important for emotional processing have real difficulty in being able to make meaningful decisions. In effect, all decision-making basically involves some level of emotion. And sometimes we make decisions on the basis of a set of procedures, but that's just because we've got a really deep emotional commitment to that set of procedures. So what people call rational is just a step removed from the emotional commitment. And it's all changeable. One of the fabulous things about affect is that you can reframe, you can redo the way that you emotionally relate to just about anything. Drives. I just want to point out here, and this, I'm not going to go into this in any real depth, but just to acknowledge that this gets close to the sort of instinctual stuff that we see in other animals. But in humans, it doesn't necessarily show up in a very ritualized way. But that doesn't mean that it isn't powerfully there for us. All of these motivations of growth, of safety, of food, of connection, sex, they're all just hugely important. And we'll get into this a little bit more when we get into the optimal zone stuff. All right, so that was affect. Let's now look at memory. First of all, memory, you have to put it in the memory and you have to pull it back out again. So the first leg, sensory, you start off with some sort of sensory experience. And then it comes in through your personal filters as to what's important to you, what isn't important to you, all kinds of ways in which you filter it. In that process, some of the material gets lost. Some of it goes into short-term memory. Maybe you then hold on to some of it, goes into a process that can take hours or even days, that's called consolidation, before it really firmly winds up in your long-term memory. Short-term memory, we run into the 4 chunks working memory limit. Long-term memory, there don't seem to be any limits about how much people can, how big the store is for being able to remember things in long-term. And there are different kinds of long-term memory. One of them is known as knowing that, and it's things like events and general knowledge. Knowing that the sky is either gray or blue, for instance, and rarely is it turquoise, although sometimes. And then we also have procedural, knowing how. Habits are the great example of this. In order to get it back out again, gets triggered by association, and it winds up activating the same parts of the brain that were involved when you first experienced it. So if you remember, if I move my foot and kick, I've done an action that involved those motor parts of the brain. If I now remember that kick, the same parts of the brain light up. So in effect, we are imagining the past. Turns out that imagination, perception, and memory all use the same basic processes. And it winds up often being much less accurate than we think. This is why, eyewitnesses tend to not be terribly good. And part of the problem is that when we try and figure out how accurate our memories are, we do it on the basis of comparing our memory with our memory of our memory. And it's kind of like using a rubber yardstick to measure itself. It doesn't. Okay. Want to move on to pattern. And we're going to have a whole little section on pattern. So I just want to say, first of all, what is this pattern? What's here? Okay. How in the world did you manage to see that? I mean, you could begin to tell me some characteristics. But this is something, again, that getting computers to do this sort of thing is really pretty tough. And yet we humans are amazingly good at it. And just like memory, there are temporal patterns, scenarios, if this, then that. And this is from an evolutionary point of view, having a memory of what happened in the past and what the consequences were. I came to this bush, I ate this berry, I felt nourished afterwards, or I felt sick. You want to know that pattern, not just for humans, but for all kinds of life forms. That kind of temporal pattern is really important. There are also these semantic patterns, just like what we did with birds, is a definition kind of pattern. And then procedural patterns, the habits, the action steps. All right, cognitive modes. So we've got this linguistic, kinesthetic, and visual modes. And I want to tie this back into the what time is it, in the sense that, in effect, in the Empire era, when writing was the high-tech form of communication, there was a very strong emphasis on the linguistic parts of our brain. And that continues in many ways up until today. You see it, for instance, in the way in which educational systems, when they need to cut something out, they cut out the visual and the kinesthetic. We still give our priorities that way. I saw that as an elected public official in terms of the procedures that we used for governance were basically all oriented towards language. My sense is that as we move into the planetary era, we're going to get a much better balance. And so it may sound tonight as though I'm beating up on the linguistic side of things, but of course I'm doing it by speaking. So I don't mean to say that language isn't a fabulous gift. It is. But the problem isn't with language per se, but that we've given it too big a part of the pie chart. So the linear stuff, wonderful, but it has to be these long strings. Its strengths, it's orderly and it's easy and it's quick and it's flexible. It's great for everyday communications, and I want to say, relative to everyday communications, language was created in small cultures, small groups, where people shared a lot of experience and shared a great deal of common beliefs. Now, especially with a language like English, which has gone all over the globe, we can no longer expect that the people who are taking the language in or using the language will share the same underlying frameworks. So that's part of the weakness. It's linear, the 4 chunks, it's low resolution. I'm going to get into that a little, what I mean by that a little bit more. And its language is essentially labels on categories, which means that it forces us into categorical thinking, even in places where that's really just not appropriate. However, it does great with time, not as a flow of time, but as a series of events. What we have in stories often are a series of events. And some events may last only 5 minutes but take 35 pages. And then all of a sudden 3 days go by in a paragraph, etc. I mean, you know how that is in stories. So that's the relationship of language to time is all based on events. Visual spatial. If you look at how much information is coming in through our eyes, if you were to create a picture that was as good as our eyes could create, the number that I've found is that it would take a camera that had 576 megapixels. That's like 20 times bigger than the current best DSLRs. However, we do that in a way that's really different from cameras. We're not just taking a picture all at once. We move our eyes around all the time, and we have this really tight area where we focus, and then we build up this amazing thing in our minds of the space around us. That foveal vision is only about 8 megapixels, but that's still a lot compared to 4 chunks. The amount of information that you can hold in a visual image is huge. On the spatial side of things, I also want to say that hearing and touch also contribute into the spatial sense. So with a visual, one of its strengths is that it's very easy to receive, and the huge amount of information, and it takes in, unlike the categorical quality of language, vision very easily takes gradations into account, and relationships, because what you see is not just a set of objects, but you see them in a space, in relationship to each other. Weakness. Well, one of the old weaknesses that's getting less and less the case is that the visual stuff was really hard to produce. I mean, you could always maybe draw something on paper, but if you wanted to then broadcast it further, original printing presses that used movable type couldn't do imagery very well. And it has no story with it, which is both a strength and a weakness. But it's a real difference. This visual scene that you have around you is just a scene. And it's not very good with time. Little short sections of time, yes, but for longer sections, vision can be made to be good with time with graphs. But by itself, it's not particularly good with time. Okay, kinesthetic, somatic. Now, one of the fun things going on right now is we all have this process called neuron mirroring. So as you look at this image, you actually vicariously experience some of that. Some of you will tune into that more than others. So it's got easy access to habits and affect, and it really is a wonderful partner, especially with the visual, but also with, it can be with the linguistic too. And it winds up being the source for a lot of our really deep metaphors. What we experience in our bodies becomes that source. Like up, the experience of gravity. It's one of those deep metaphorical experiences. Hard to translate into categories and words. For some people, that's a strength, but it winds up being a weakness, especially in a culture that sees words as the primary legitimate means of communication. But if you're willing to mesh the kinesthetic with the visual, and this is what happens with sports, with a big sports game. And all these people go to watch the sports game. And they vicariously experience the kinesthetic process for those athletes. There are other things going on too. But that's one of the things that is a powerful draw that connects us into that. or with skaters, or with dancers, or with gymnasts, any of those things. We watch them in awe, and we experience, in some degree, what they're experiencing. And the kinesthetic somatic piece has a wonderful connection to time. It's in our bodies, it's the rhythm, it's the flow. And so it connects us into a dynamic sense of experienced time that's different from the sequence of events with language or just a sequence of images. So I'd like to next play with something that will kind of draw these three cognitive modes out a little more by looking at color. And this draws on something. How many of you know the cartoonist Randall Munroe, who does XKCD? Okay, so he was a NASA scientist, I think, or an engineer before he decided to become a cartoonist. So he has these interesting ways of looking at things. And at one point, he decided that he wanted to find out what people actually thought color, what were the color names that should go with various different colors. So he put up a survey, and because he's a popular guy on the web, he got over 200,000 responses from people who looked at various color chips and said, this is the name that goes with that color chip. And then he put them together. He mapped it out in terms of what names go with what colors. And let me just zoom in a little bit more so that you can see the center part there. So there's some issues here in terms of wide stretches of color, all under the same name. This is a composite of many, many different people. Any one individual would have a slightly different mapping. So it's great that we can name colors, but there's only so far that we can actually push the naming of colors. Now, some people try to push it further. So you may not be able to see this, but that's...
Candy Tuft.
Yeah, Candy Tuft,
Sugar Sweet,
Sugar Sweet, and something pink. So we get into marketing jargon for colors. The linguistic evidence suggests that most cultures at this point only use about 12 words. I think Randall had about 24 words because he was pushing it. But in terms of what people actually do, we only use about 12 words for color. So how can we possibly deal with color? I mean, we're back into that 4 chunks of working memory kind of problem again. How can we deal with color in a richer way than doing it linguistically? So this is what I'd like to show you. Anyone who these days is using a computer program that uses color probably has some kind of color picker. Well, I want you to think about the color picker as this mixture of visual and kinesthetic. Sliders are the wonderful kinesthetic gateway between computers and your muscle memory. So I'm gonna, if I can get this to work, we'll see. Let me just go off here. Yes, here we go. We've got 3 basic concepts here of hue, saturation, and lightness. I can change the hue anywhere 360 degrees of hue along here. I'll put it down about like so. And then I can change the saturation. This is fully saturated up here. If I pull it down, it becomes grayer and grayer and grayer until down here it's all the way gray. And in a similar sense, I can add black or I can add white. And it really doesn't take that long to be able to access the 3.6 million colors that are available here in a way that becomes easy, intuitive, muscle memory kinds of things. 2 people can sit down and do it together and never have to name the color. But they can agree on a color together. Or you can take those numbers, send them off to somebody else, and they can come up with the same color.